Hey, here we go again. Got another task for you guys as we're rolling through our engineering design. This one again took a little bit of creativity, but I'll show you how I used some of my resources to figure out which one I wanted. But well, let's jump into it. Today we're going to be dealing with day 10. So we're opening the alternative solutions task. So again, I have above me the coding system. And then let's see if I do this right. Oops. Over here is our directions. I think I did better that time. So the alternative task solution, we're going to have to design and build a model of a motor-driven security barrier that can be raised and lowered. We're going to follow the criteria in the brief and ensure that it works properly. And then what you're going to have to do in your notebook is give a list of where you have the motor and switches plugged into the brick. So you just have to give me a list of where everything is put, and I'll be able to help you with that before the end of our task here. And then you're going to take a quiz. So make sure you do that. All right, so let's go ahead and jump in. Again, alternative solutions task. Let's back out. Alternative solutions task. So we finished our notes. We're on to our task. So here's a task. Let's go ahead and get started by listening to the directions.
Lab work. Alternative solutions. Security barriers are used to control the entry of vehicles to factories, parking lots, military bases, and many other locations. Security barriers are usually driven by an electric motor through a mechanism. Design and build a model of a motor-driven security barrier that can be raised and lowered. Use the help sheets for assistance.
All right. So here we go. I kind of have my brick already set up, and you can see I got my cords all hooked up. I don't want to mess them up, but I'm practicing to make sure it's good. So here's our brief. The barrier should start closed. I have it set at closed. When we push the button, the barrier is going to go up. When we push a second button, the barrier is going to go down. So that's why you can see two different cords here. One goes up, one goes down. One goes up, one goes down. Okay. So here's the things we have to be aware of. We have to sketch at least two different designs for the motor-driven barrier and build one of your designs. I'll show you the sketches, and then I'll show you the design. We're going to use the programming software to program the motors. We're going to connect the motors. We're going to use the controller. We're going to download it, and then we're going to decide if the method works well by testing it, and then evaluate the model and suggest any improvements. So here we go. I'm going to show you my sketches first. So here are two sketches. I wonder if I can make them bigger. I can't. Here are two sketches that were created, just kind of the thought process of it. And then here's what it's going to kind of look like. Pretty similar. This down here is what you're eventually going to be putting in your notes for your activity today. And I think I'll have you do the sketch here as well. I want you to sketch what the design looks like. So I'll add that at the end. Yeah, I'm sorry I added more work for you guys, but I think it's important to do that. Actually, let's do it right now. And a sketch of the design or the build. The sketch of the build. Works good. So let's get into showing you how I program this. So the first thing I noticed is I need to create something. I have to help create something that goes up and down. So I went into the support materials looking for something to help. Helicopter was going to help, conveyor, no, turntable, gearbox. When I looked at the gearbox, I thought this is something that I'm going to need to be able to make it go up and down. So the gearbox is what I created. Now, I just picked a left side gearbox. It really doesn't matter, but left side seemed best for the way I was going to lay it out. And then I realized I don't need that wheel. I'm going to be making an arm to it. So I just adjusted it. But really, I followed this, used the kit. I used everything on this list except for the wheel. And I went through, put it all together just as it showed, which was really nice. Now here's where it gets tricky because we got to have all these gears because here's our input gear, right? Little teeny tiny one. And I had to makeshift the shaft so it keeps coming in and out. So this wouldn't be perfect for a durability to last forever, but I put that little gear in there so it'll hold. And then you got to put all these other gears that are eventually going to go to the output gear, which is going to be the shaft. And these allow for directions to go up smoothly. And again, as you've probably learned in previous lessons in school about machines and stuff, the more we have here, the less output work we're going to have. So these all help to build together. So I'll kind of assemble them together. A little puzzle piece had to fit perfectly. So you can see that these big gears have small gears attached, and then the small gears attached to the big gears, and it's a chain. It's a gear train. Makes it a gearbox. So all vehicles have these gearboxes. That's how they shift gears to be able to go faster. And then here's the back side of it. Put it together, and then I just skipped that part. I put a long shaft on, which I'll show you for a barrier. So I use that to help build my solution. So then, as I've shown you guys before, here on Google Classroom, I added the programming. Forgetting my words here, and I called it security barrier. So now what I'm going to do is I'm going to go over here and I'm going to start programming the security barrier. But before we do that, I want to show you how it's all set up. So in output gear, I have a switch, and when clicked, it's going to allow for the barrier to go down. And then switch 1 is up. I think I have that right. Up, down. I program these and I still get confused. So we'll see how it works. I'm doing this just one shot, so we'll see how it works. Now, as far as the gearbox and everything looks, here's how it turned out. So I actually used the same motor, and this setup was all set up already from the turntable. So I already knew how to build that. This is the gearbox that was all created. Okay, here's all the gears that are inside. Here's how it turned out. Again, my input gear, this little teeny tiny one, is the one that's giving me trouble down here. And it keeps popping out, so I got to keep watching that because I don't think I had the right shaft put in. And then on the output here shaft, I have the barrier that's going to go up and down. So hopefully we're going to see this work successfully. And then I took these pieces just to make a little stand so that the motor isn't having any pressure. It's just kind of sitting neatly on there. Okay. So let's go ahead and open up the code. The code. Security barrier. Shrink down my screen here so you can see this. So this is how we set it up. Again, I made an infinite loop. So it will keep running and running and running until I want it to stop. So here, switch input 0 switch. So that's the first switch right down here. This is set as an open loop, and it's set at negative 75 speed. The reason it's set at negative, it's going the opposite direction. So that's all negative means. It's going to go the opposite direction than what you normally would want it to go for. We're going to have it go up for 4 seconds and then stop. Now, I can keep pushing that button over and over and over and over, and it'll keep doing what I want it to. But then when I go to switch 2, which is an input 0, this is going to make the thing do almost the exact same thing, but opposite. Positive 75 for 4 seconds. So we should be able to go up and down, up and down. I had to remember the way I set up the gears here for which way it was going to go up and which way it was going to go down. I think I got them, but now that I've been thinking about it, I think I'm going to mess it up, but we'll see. I'm going to hit that escape button on this brick really fast if I need to. So everything seems to be set up right on here. So now all we got to do is pull that USB cord. And this is the same thing you'd be doing if you're in class too. You can do these. You could have set this up too. And this is the hint I would have given you, which is go make the gearbox. The gearbox is the key there. Okay, let's go ahead and download. Okay, now again, this is all in a loop over here, so it will go back and forth until I stop it. Again, I have this little gear I'm going to be watching in here to make sure that it sits. You guys can't see it, but I can see it, and trust me, I'll be watching that. So now that I got it downloaded, unplug my USB. Program. Again, it's just program A, just copying over the other ones. And here we go. So if I switch 0, it's going to go negative. It's going to go negative. If I hit 1 or switch 2 or whatever, it's going to go positive. So let's see if I got this right. Oop, got it wrong. Got it wrong. Got it wrong. So I hit the wrong one at the wrong time. That happens. Now, to not mess with the motor, I'm not going to crank on the motor, I'm just going to reset my thing here. And now that I got it, let me just bring it down now that I know which one's the right one. I'm going to hit escape. Went the wrong way. Okay, let's hit it the right way. Stop. Okay, now we got it all set up. So using my switches, I'm going to make sure I can get this to work right. Okay. So we want it to go up, and then we want it to go down. Here we go. Up for 4 seconds. And again, it'll stay there. Oh, the gear fell out, so I'm just going to slide that gear back in. So it holds there, and it did exactly what it's supposed to. It went up, and it got out of the way. And then you have a second switch, so when someone is done driving past the barrier, you can hit that button, and the barrier will come right back down, and it will stop it. Okay, I'm going to bring it down just a little bit and stop it here. So now it's all the way at the bottom, so no one can drive through. So again, if we have someone coming through and we need to allow them to come up, they would stop at the security gate here, and the person would go, okay, let me see your papers. Do you have your papers? Okay, you can come through. And then they open it up for them. Right? And then once they're driven through, the guy watches, takes a sip of coffee, and then hits the other button next to it. Now you can see why it would be important in the real world to label your buttons up and down. This is down, and this is up. Okay, so up. And down. And it's fun just to play with it back and forth. And I gotta be honest, it's always exciting when this works. It's like, yeah, I made this work. That was me. I did that. So that's how we set this up. Okay, so to be able to see everything and see the switches, there we go, and see the switches. Now what you're going to do in your notes is you're going to, oops, wrong thing. You're going to give a list of where you have your motors. So make a little spreadsheet in your notes that show where the motor is set up and what port. Okay. And then here are the switch 1 and switch 2 where they're set up in their port. I'm going to move this screen so you can see the code again. But again, you could always see the code too. But here's where you can see DC motor. Switch 2 is in what port. Switch 1 is in what port. So that's all there. There's the DC motor again there. There's the DC motor again there. And then sketch what the build looks like. So what does this picture kind of show you? What are all the things that you see that I put together for it? Once you have those down in your notes, then all you have to do is go take the quiz on the alternative solutions task. And again, if you don't pass 80 or higher, I will reset it for you. So that is the day 10 task. It would have taken you the whole class to build. Trust me, because it took me the whole class to build. So just make sure you got your sketches down, you got your spreadsheet put there, and then you are done for today. And good luck on taking the quiz. I don't think you'll find it to be too difficult as you work through it. And we will for sure see you next time. And thanks for watching.